This is a problem from quadratic equation. Here we are given a quadratic equation x square plus 6x is equal to 27. We have to solve this equation by using completion of squares. For that, we have to add the square of the coefficient of x, that is 3 square, on both sides of this equation to make it a perfect square. But students may not be able to know why do we add the square of the coefficient of x. In the case of b is equal to 5, we have to add the square of 2.5, which is a half of this 5. Then, in order to explain that, let us move this slider a bit. Then listen what's happening. The lower edge of this yellow rectangle splits into 2. And we can place this small strip on the top of that square. Then in order to make it a perfect square, we have to add a small region here. That region, area of that region is 3 square. You know why it is 3 square? Because this is the half of 6. Therefore we have to add 3 square. When we add this 3 square, it will become a perfect square. That is the case here. Then after adding this 3 square on both sides, x square plus 6x plus 3 square is a form a square plus 2ab plus b square. Therefore, we can express that in the form a plus b whole square. This also is a perfect square. Therefore, we can write it as x plus 3 whole square is equal to plus or minus 6 whole square. Then avoiding squaring on both sides, we will get this equation. It has two cases. If we consider the first case, x plus 3 is equal to 6, the value obtained is x equal to 3. When we consider the next case, x plus 3 equal to minus 6, x plus 3 is equal to minus 6, the value obtained is x equal to minus 9. Here, if it is a practical problem, if we consider this a practical problem, x is a length of a side of a square. It cannot be negative. Therefore, if it is a practical problem, x is equal to 3 is the only solution. But if it is a mere quadratic equation, it has two different solutions, distinct solutions. Okay, if we move forward once again to repeat with another variable, parameter 5 or 4. Let's try 5. Then in order to make it a perfect square, we have to add half square of the half of the coefficient of x, that is 2 square, has to be added on both sides. This is a geometrical interpretation of adding the square of the half of the coefficient of x. Then after adding 2.5 square on both sides, we can express that in this form, and avoiding squaring, we will get two cases. First case, x plus 2.5 is equal to 6, and this 2.5 can be shifted to this side with reverse operation to get the value x equal to 3.5 as one solution. If we consider the second solution, second equation, x plus 2.5 is equal to minus 6, x equal to minus 6 minus 2.5, because we shift this plus 2.5 to the other side of the equality with reverse operation. X is equal to minus 8.5 is the value, another value of x. Here we have two distinct solutions to this equation. And if we change this value of b, we will get different answers. The interesting thing is that when we change the coefficient of x, we will get different solutions. All these solutions in the software depends the value of b. If we change it, we will get different values and different interpretations also. Thank you.